In this concept, we're going to talk about congruent figures and polygons. If two or more figures have the same size and the same shape, then they are called congruent figures. The corresponding parts of congruent figures are congruent. Okay, so in algebra, we used equality, right? X equals, 3, 2x minus 5 equals 0, etc. So we used equality in algebra, right? But in geometry, we call it congruence. But it's essentially the same concept, okay? For congruence, a geometric figure needs to have, or two geometric figures need to have the same size and the same shape. Let's look at this example. In the figure below, the two triangles are congruent, meaning they have the same size and shape. Therefore, all of their corresponding parts are congruent. Okay? So triangle ABC, and triangles DEF, right? Every side and every angle is equivalent to the same side or same angle in the other triangle. Okay? Every side or angle in one triangle is equivalent to the same side or angle in the other triangle. So segment AB here, right? This segment is equivalent to segment, or congruent to segment DE. Segment AC, which is this one, double dashes, is congruent to segment DF, this one. Segment BC, this one, is congruent to segment EF, this one. Okay. Same for angles. Angle A is congruent to angle D. Angle B, which is this one, is congruent to angle E. Angle C, which is this one, is congruent to angle F. Okay. And just something to note, to name congruent polygons, the corresponding vertices must be written in the same order. So in the example above, when we want to say that the two triangles are congruent, we have to say triangle ABC is congruent to triangle DEF. Okay? If we name this triangle ABC, then we have to name this triangle DEF. For example, if we were to name this triangle triangle BCA, right? Then we'd have to say it's congruent to, again, same order of vertices. So we'd have to name the other triangle EFD. Okay? So keep this in mind. Order of vertices has to be the same to show congruence. Okay? Let's look at this additional idea of third angle's congruency. So if two pairs of angles of one triangle are congruent to two pairs of angles in another triangle, then the third pair of angles is congruent. Here's an example. So we have these two triangles, right? ABC and DEF. So clearly we can see that angle A here, single arc, is congruent to angle D, single arc. Angle B is congruent to angle E. Therefore, angles C and F, which are the third angles, have to be congruent, right? And why is that? Because all three angles in any triangle, in this case, right, have to add up to 180 degrees. So if the first two pairs of angles are the same, then the third pair of angles has to be the same. Okay? Here's an example of this idea. In the figure above, what is the value of x? So we have angles A and D are congruent, angles B and E are congruent, and then we have angles C and F. Okay? And x here is the measure of angle F. Okay? And the measure of angle C is 50. So clearly, angle C is going to be congruent to angle F, right? Which means that x equals 50 degrees. Okay. And here we have our exercises. Please pause the video, work on these, and come back for the solutions. Okay, so list all the corresponding parts of the congruent triangles below. So we are given that the two triangles are congruent, and we can clearly see by the symbols of each of the corresponding segments, right, or angles. So clearly line FG, or segment FG, is congruent to segment LM. Okay, and then segment GH is congruent to segment MN. You may want to have like a double dash here and a triple dash here, you know, because these do not look like they're isosceles. So just to distinguish them, right? And then segment FH is congruent to segment LN. So segment FH is congruent to segment LN. Okay? And the same for the angles. So angle F is congruent to angle L. Angle G is congruent to angle M. And lastly, angle H is congruent to angle N. Angle H is congruent to angle N. Okay? Second exercise, find the measure of angle C. So again, we have two triangles with two pairs of angles congruent, right? So A is congruent to D, B is congruent to E, therefore C, angle C, has to be congruent to angle F, right? Which gives us the measures of them are equal, so we get 6x plus 5 is equal to 2x plus 65, right? I can subtract 5, and then subtract 2x, subtract 2x. So we get, these go away, 6x minus 2x is 4x, and then these go away, 65 minus 5 is 60. So 4x equals 60, so x equals 60 over 4, which is equal to 15. But we're being asked to find the measure of angle C, okay? So now that we have x, we could just say the measure of angle C is equal to 6x plus 5, which is equal to 6 times 15 plus 5. So 6 times 15 is 90, right? 90 plus 5 is just 95 degrees. Okay? And this is it for this concept. See you in the next video.